So we are doing circle properties. This is a subsidiary topic. Subsidiary means that it is not the main topic like statistics, mensuration, and probability. We have done some main topics. Circle properties is related with the angle properties in a circle. And we are talking about a perpendicular drawn from the center of a circle to a chord bisects the chord. Now you look at this diagram. From center, we have drawn a line which is dividing the chord in two equal parts. Now I have put another concept. I have connected. Look at this screen. I have connected the two radii. I have connected two radii from the two centers. It means the two sides are equal, and such a triangle is called isosceles triangle. It would be better if you draw, if you want, you can update the same diagram, or
Yes.
you can make a new diagram for the clarity of the notes.
Okay. Okay.
Now, putting the second property, angles in the same segments are always equal. Angles in the same segments are always equal. You have to copy this property.
Okay. Okay.
Now look at this property. It is called a zigzag property. It is famous by this name. It's like a scissor. It's like a butterfly, and there are four corners. 1, 2, 3, and 4. The four corners are on the circumference. The four corners are on the circumference. The two positions are equal. The two positions are equal. The two positions are equal. So it means this angle, which is facing this angle, are always equal. This angle will always be equal to this angle. This property means that in a circle, if you make a zigzag four corner figure, the angles facing each other are always equal. So you have to copy this screen.
Okay. Okay.
angle subtended by the diameter of a circle is always 90 degree. You have to copy this property now.
Okay. Okay.
Now this is the property. This is the diameter. From the diameter, you make a connection here, and this angle is 90 degree. So whenever you make a connection from the diameter, this angle is always 90 degree. You have to copy this screen.
Okay. Okay.
Number 4, opposite angles in a cyclic quadrilateral are supplementary. Supplementary means the sum is 180.
Okay.
So copy this screen.
Okay.
Look at this screen. The opposite angle, first of all, what is a cyclic quadrilateral? Quadrilateral is a figure with 4 corners, and cyclic quadrilateral is a quadrilateral which is inside a circle. Quadrilateral is a figure which is inside a circle. Look, these angles are facing each other and their sum is 180. When two angles sum to 180, they are called supplementary angles. You have to copy this screen.
Okay. Uh, okay.
For a cyclic quadrilateral, the exterior angle is always equal to the opposite for a cyclic quadrilateral. The exterior angle is always equal to the opposite interior angles.
Yep.
So this will be our property number 5, I think.
Yes.
This is property number 5. So now you have to copy this property.
Okay. Okay.
Again, a cyclic quadrilateral is there. Now this is called the exterior angle, and this is called the interior angle. These two angles are always equal. These two angles are always equal. So now you have to copy this property.
Okay. Okay.
So we are now moving to our property number 6. Radius and tangent are always perpendicular to each other.
Okay. Okay.
Look at this diagram. Look at this diagram. Radius is perpendicular to tangent. Radius is perpendicular to tangent. So whenever you draw a tangent to a circle, radius and tangent are perpendicular to each other. You have to copy this.
Okay. Okay.
Now we have to do number 7. Two tangents drawn from the same point to a circle are always equal in length, and they subtend equal angles at the center of the circle and also at the starting point. You have to copy this.
Okay. Okay.
Then you have to look at this diagram.
Okay.
Now look at this diagram, and there are two tangents coming from the same point. The point is P. From P, we have drawn two tangents. From P, we have drawn two tangents. And one tangent is touching position A, one tangent is touching position B. This is 90 degree. This is also 90 degree. When you draw two tangents from the same point, when you draw two tangents from the same point, what happens? The two tangents are equal in length. They both are equal in length. This is radius, this is also radius. So both tangents are drawn from the same point. And
Yes.
when you reach the position, the two radii here, this one and this one, are also equal.
Okay.
Then you have to copy this screen.
Okay. Okay.
Angle between a chord and a tangent is always equal to the angle in the alternate segment. This would be number 8, I think.
Yes.
Angle between a chord and a tangent. Angle between a chord and a tangent is always equal to the angle in the alternate segment.
Okay.
Have you copied it?
Yes.
Now, look at this property. This property is a bit difficult. This is a tangent and this is a chord. Angle between a tangent and a chord is always equal to the angle in the alternate segment. So once you get angle here and you go from here and you take the first turn, then you take the second turn. This angle is equal to this angle here. So the two angles are always equal. The two angles are always equal. This is the property. The two angles are always equal. So what we do, we always check this property that when you take the angle between a chord and a tangent, and you go from there and you take the first turn, then you take the second turn. On the second turn, you will always get the same angle.
Okay.
You have to copy this property now, this screen.
Okay.
Angle at the center is always twice the angle at the circumference. This is the property number 9. Angle
Okay.
at the center is always twice the angle at the circumference. You have to copy now number 9.
Okay. Okay.
Now this is the property. This is our diagram. Look at the corners. 1, 2, and 3 corners at the circle. These are the 3 corners at the circle. And we have X here and we have 2X. O is the center of the circle. X is the angle at the circumference. Angle at the center is twice. Angle at the center is twice the angle at the circumference. So this angle is 2x and this angle is x. So this
Yes.
angle is twice of the angle of the center. Now you have to copy this screen.
Okay. Okay.
This is another view. This is another view, and this is the angle at the center. This is the angle at the center, and this is the angle at the circumference. Now, this angle is doubled here, and you have to cross this line, and then you have to get this double angle. So this angle is always twice of the angle at the circumference.
Okay. This is 9 or 10?
Sorry, can you repeat?
This is number 9 or number 10?
No. It's number 9, but number 9, another approach. Here, you take this
Okay.
angle and you take this angle. But when you come here, here, it is the same property, but the appearance, the angle positions are different. So you have to remember that this angle won't be double here. It will be double across the center, always. You have to now copy this screen.
Okay. Oh, okay.
This is another version of this property. Look again, how you check this property in the paper. You will count the number of corners. 1, 2, 3. 3 corners on the circumference and 1 corner at the center. 1 corner at the center. So this angle is x, this angle is 2x. You have to copy this.
Okay. Okay.
Now, do you have the book 4 with you, the past paper book 4 with you?
Yes. Okay.
Have you shared the content list with me before?
Content list? No.
The content list of the book. I think you had shared me with me once, perhaps.
I can share it right now.
Okay, if you can share book 4,
Okay. Okay.
Hmm. Geometry construction. I think it should be 4.3. It should be
4.3.
included 4.3. What's the meaning of this multiple? Is it read and write or it is MS books? This book.
Read and write.
Okay. So can you check unit 4.3, and if you find some circle diagrams there, let me know.
Okay. Yes.
Are there any circles there?
Yeah.
Good. So just do one thing. Come on the content page
Okay.
and write in front of 4.3 circles.
Okay.
So it will be a memory for us also that this topic contains circles.
The first question is October, November 18, P42.
October, November 19.
18, P42.
Question number?
7. Yes, that's
Now look at this question number 7. In the diagram, A, B, C, and D lie on the circle center O. Find angle BAO. Find angle BAO in the diagram ABC and D lie on the circle. EA is a tangent to the circle at A. So it means that this angle would be 90. You should work with me with pencil. Uh, work with me with pencil so you can rub it, and because after one or two parts, this appear to be very smudge. This line is equal to this line because their radius is asking to find angle BAO. BAO. Look at this angle. I have made it blue.
yes.
Now, if the total angle is 90 and I have a 61 also there, how can I find this blue angle?
90 minus 61.
Good.
Twenty-nine.
Find angle AOC. This angle.
Yeah.
Can you first help me to find this red angle? The total
Uh,
angle in the bottom is 55 and the blue angle is 29.
so 7.
Uh, no, it should be 6. Why 7?
Oh yeah, sorry, 6. I wrote 91.
Hmm. So if I go inside OAC, OAC will be equal to 61 minus 55 is equal to 6 degree. Okay, the two lines are radius. This is a radius, this is a radius. So can you tell me that what about this angle facing? If I make it green, this green angle. What about this green angle?
This triangle will be 55
No, the red angle, green angle should be equal.
to 61.
It should be 6 degree now.
Oh, 60. Okay,
If
because it's
this
opposite.
angle is 6, this angle should also be 6. Why?
Yes, because it's the rule. It's opposite.
Because O, if after the two radii, O is C, will it be isosceles?
Isosceles. Yes.
Why?
Because it's the both
Two
angles are opposite of
sides
each
are,
other.
because two sides are radius.
Oh, radius. Okay.
In the paper, you have to do some working to justify. I got that 6. Now I know two angles in the triangle are 6. I think we are making some mistake. This 6 is not looking right. Look, let me check again. BAO, our working approach is right, but we are taking a wrong number. Look,
Oh,
actually, the mistake is coming that the blue angle is 29. The blue angle is 29. If the
yes.
blue angle is 29 and the total below is 55, what should be the red angle?
Uh, 55 minus 29.
55. So this is a mistake.
So it'll be 26.
5 minus 29. How much? 26.
Yes.
Now, this angle is 26 and this angle is also 26. So can you find the angle at the center?
Uh, uh,
I know two angles in a triangle. How can I find the third angle?
we
O
have to add
plus 20.
180.
Yes.
Yeah.
Sum of angles in a triangle is 180.
Uh, So 180. 128.
Find angle ABC. So now examiner is talking about this angle. We have got the angle at the center, which is now 128. If we know the angle at the center is 128, how can I find the angle at the circumference? What was the property? I write the property angle at center is twice
By the angle at the circle.
twice the angle at circumference. So if I have 128 here, I can find ABC. ABC is equal to
256.
128 upon 2.
Oh, sorry. So
So I have mentioned the
64.
property. Even you look at the screen. Whenever you're solving this chapter, whenever you're solving questions on circle graphic,
Yes.
you can use a very interesting technique. All answers should be physically lookable, physically observable. Remember, I first wrote 6 on the red angle. Then how I
Yeah.
felt that this is wrong, because the size of the angle, the size of the red angle is not looking like to be so small as 6.
Yeah.
Similarly, whenever you get an answer in this chapter, you can physically feel it that this angle cannot be the size.
Yes.
CDA.
EPA. 64.
We got 64 here. First we see. Now we are finding this angle.
Okay. CDA. Okay. Will it be the opposite 64?
You can look at the properties.
Okay.
What is the
One.
property? Opposite angles. Opposite angles in a cyclic quadrilateral are supplementary.
Supplementary. Okay.
Achha,
So
now you can
128.
idea. If just look, feel the size of 64. Can you think? Can you guess? Just like a wild guess, do you think it can be 64 also? Look at its
No.
size. No, it is
Yeah, it's
looking
smaller.
at, is it visible that it is an angle greater than 90?
Greater than
This angle,
mm,
if you look at closely, this angle is surely greater than 90, this question mark.
yeah. Yes.
So supplementary means sum of angle is 90. So it will be CDA. First you look how it is a cyclic quadrilateral. 1, 2, 3, and 4. Look how many corners.
Corners 1, 3, 4.
4 corners. It's a cyclic quadrilateral.
Yes.
It is a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles sum to 180. So you will tell examiner first. You will tell the examiner first that A, B, C, D is a cyclic ABCD is a cyclic quadrilateral. So 64, the angle facing 64.
Um, So 11116. Okay.
Now look for the question after that.
October, November 18, P41. Question 10. Question 10. Yeah.
The diagram shows a circle center O. The straight line ABC is a tangent to the circle at B. AOB is equal to 8, AB is equal to 15, BC is equal to 22.4. AO crosses the circle at X and OC crosses the circle at Y. Calculate angle XOY.
XO.
This angle.
So
I have made the first step.
uh
Now it's a triangle.
if we add them both,
But we do not know any one of them, no? So I think I should first make it. This red angle. Can you find this red angle using trigonometric ratios?
red eye. One 180 minus 90.
No. Why you're not thinking about uh, the ratios of triangle sine, cos, tan?
Oh, okay. Um, so the answer is 39.8.
This x,
Yeah. The previous X.
what is x? 39 point.
8. So 79.6.
So you just double it.
Yes.
So after doubling, what you get?
79.6.
So we stop here and
Okay.
we will inshallah continue because we have done the theory of the chapter. We have done we can do the question in the next class.
Yes.
Please try to send me the homework in PDF form if it is possible.
Okay. This
Thank you.
is zip file. You can just open on a
I know,
computer
but
and
in mobile, it takes time and the sheets are separated. Now, if it is in PDF form,
oh,
I can scroll it easily.
yes. Okay.
Thank you.